In this tutorial, we will see how to download and use Crop E Bal, which is a program to calculate the crop energy input and output typical of different species. At the web page of Fitotecnia at Universidad de Córdoba, we click on Crop Energy Input Output, which is the program, and it will download automatically. And once it is downloaded, we can click here and then the program will be running. We see that this program is digitally signed by Universidad de Córdoba, therefore we can check that the program is as it is released and there is no problem with viruses or whatever. We remove this box and then we click on Run, and the program first shows us the first form where we can select the crops to add to the rotation. We're gonna see how to grow wheat, durum wheat. We add it to the rotation. If we don't add more crops to the rotation, we will assume that it is a monoculture of wheat. Let's assume that we are producing 3.5 tons and that we are leaving 10% of the residues in the field, and the remainder 90% is exported, is sold out of the farm. We will be burning the residues, so we click here and we can select the type of soil. Let's select clay loam. We are not going to apply irrigation. If we apply irrigation, we would select different characteristics of the irrigation system. We proceed, and then first of all we add the tillage operations. We are going to apply moldboard plow. Here we could apply more than one operation of moldboard plow. Let's keep it in one. This is the depth. We could change this, and air means not required. For some implements, we could specify here the separation between the different tools of the implement. We're gonna do also some this harrowing. We're gonna do 2 these harrowings, and we will also do some field cultivation, secondary tillage, just 1, and then we will select the sowing operation. To do that, we will use a grain drill with press wheels. It is automatically added to this box. We could change here the depth of soil. Let's keep it at 3. We could here review any of the depths of the different operations. We proceed, and now we have other types of operations. Let's apply fertilizer. We're gonna apply fertilizer twice during the growing season, and we will apply pesticides 3 times during the growing season. Finally, we have to define the harvest operation. We will combine with small grains. SP means self-propelled. We add it to the operations. If required, we could add more labor to the operations in the field, drying of the harvested organ if required, or we could specify the distance for labor to travel to the farm. Apart from that, we can specify how far we have to move the products to the final destination, by road, train, or sea. Let's imagine that we only move 50 kilometers by truck. Click on Proceed, and then we see that for durum wheat with 3.5 tons, these are the suggested values of nitrogen. We could be more accurate with that using another program like FertiliCalc, because this is calculated according to the exports of nitrogen, phosphorus, and potassium multiplied by 1.2. So we have small excess over exports of nutrients. We are not applying water here, and for pesticides we are being applied pesticides 3 times, and every time we are applying 1 kilogram per hectare, so we assume that we apply a total of 3 kilos. The amount of seed is 90 kilograms per hectare. We could change any one of these boxes we could change. We click on proceed, and then we will see the results. We see the calculated energy associated to fertilizer materials, more than 7,000 megajoules per hectare, fertilizer application around 100, the energy associated to the seeds, 1.4 gigajoules. We have 570 megajoules per hectare for the operation of sowing, 210 for tillage, around 100 for harvest, 150 for pesticide application, and more than 1,000 for pesticide materials. The energy associated to transport is shown here. For labor is only 9, and this is the sum of energy in yield, and this is the sum of energy in exported residues. The total output is 118,000 megajoules, while the inputs was around 12,000 megajoules per hectare. So the output, the ratio output over input is around 10, and these are the amounts of energy invested per kilogram of harvested of fresh harvest product, or megajoules per kilogram of harvested dry matter. We see also that the values for the rotation are equal to those of wheat. Why? Because the rotation is with monoculture. If we had several crops, here we would see the average for the different crops. Then we can check the results in a results file that specifies many of the inputs, the amounts of nitrogen, phosphorus, and potassium, and then we will see the energy associated to materials or operations in the farm. We see also the results associated to the total rotation, first for each crop and then for the whole rotation.